Okay, this was a tricky problem for a lot of people, but it's actually quite straightforward. They want to know, is that parallel to that? That's the question. Okay, we don't know if they are, but it turns out if we use the triangle, the converse of the triangle proportionality theorem, I don't really care if you call it the converse as long as you know it's triangle proportionality, then we can say if this compared to this gives you the same ratio as this compared to this, we know that those two have to be parallel. These have to be parallel because that will only happen if they're parallel based on the triangle proportionality theorem. So let's set that up there. So we're going to check 14 out of 35. Does that equal 10 out of 30? There's a couple ways you can do it. One is just reduce the fractions because they're pretty easy. This is 1/3, and if you divide this by 7 and divide this one by 7, you will get 2/7, which are actually close to the same but not equal. If you really want to reduce this, you can divide them both by 2, and it's 1/3.5, which is clearly not equal. So again, so you can say no, not similar triangles. So this was actually called A and C, and this was called F and G. So AC is not parallel to FG. And there we go, really quick.